8-70. Use the clues in the graph below to write a possible corresponding equation in y equals a times b raised to the power x form. Here is our graph, and this is not a slope, it just tells you the coordinates of the next point. So this is 0. If we go right 1, that's the coordinate 1. Okay, so that tells us the x coordinate is going to be 1. Here the y coordinate is 4, but we're going up 3. Up 3 is 7. Alright, so basically we have a second coordinate 1, 7. I suggest to make a table, and we have 0, 4, 1, 7. We want to use this equation, so don't use y equals mx plus b. Don't do that one. The starting value is a, and as you can see, the y-intercept, or the starting value, is 4. So a equals 4. And then the way you get the multiplier is you divide two terms. Always divide the later term, the second term, divided by the first term. So this is 1, 7. Let's do the 7 first. 7 divided by 4, and that is 1.75. So b is 1.75. All right, I'll let you write the equation. That's the answer. On to the next one. Okay, 8-71. I'll do B. B, you can see that 30 plus 120 is 150. And if we add 120 again, we don't get 170. So what this tells you is it's not an addition list, so we know that it's not going to be arithmetic. Arithmetic. It's not going to be that one. It's going to be geometric. Alright, so we tried adding 120, but it wasn't a constant difference. Let's try multiplying. Remember, the trick is you take the second number and divide it by the first number. 150 divided by 30. 3 goes into 15 5 times. So 30 will go into 150 5 times. Alright, 30 times 5. That's our multiplier. Is 150. 150 times 5 is 750, and we keep multiplying by 5. That's a match. Alright, so our multiplier is 5. Now we need to find the 0 term. What number times 5 is 60? And that's 6. Another way you can do it is to go backwards. Instead of multiplying by 5, you divide by 5. And 30 divided by 5 is 6. Alright, so our 0 term is 6. That tells us that a is 6. So we write y equals a times b raised to the power x. That's going to be y equals 6 times 5 raised to the power x. Now it says sequence, so I should be using, instead of y, I should be writing t of n, f of n, something like that. And instead of writing x, I'm writing the letter n. So sequence means use n instead of x. But it's basically the same equation, just that x is replaced by n, and then you write y as t of n. This is called function notation. (8-74). This problem is the checkpoint for rewriting equations with more than one variable. It will be referred to as checkpoint 8a. Solve each equation for the indicated variable. Let's do A. Solve for y. Alright, so our goal at the end is y equals. Okay, step 1. Let's add 3x to both sides. So it's 5y equals negative 10 plus 3x. We write them side by side. because they are not like terms. This one has an x, this one does not. Now we have 5 times y. To undo the multiplication, we divide. Divide everything by 5. That gives us y. Negative 10 divided by 5 is negative 2. 5 goes into 10 2 times. And then 5 does not go into 3. Let's leave it as a fraction. And that's our answer. Now this is a equation of a line, so it's nice to write the x term in front of this equation here. So it's y equals 3 over 5x. The 3 over 5x comes first, and then we have a negative 2 at the end. That's optional. This is also a correct answer, either or. All right, I'll let you solve B and C. On graph paper, graph triangle ABC if A is 3, 0. So this is X, this is Y. And that's A. B is 2, 7. And C is 6, 4. All right. We are told to investigate the slopes and side lengths. So let's look at AB. The slope of AB, if we make a little slope triangle, 1, 2, 3, 4, 5, 6, 7. It has a rise of 7, and it has a run of 1. So that's 7 up and down, and then 1 left and right. 7 over 1. Also note that if you trace this line from left to right, it's going downhill, it's negative. So the slope is negative. And we can simplify that. Negative 7. All right. And then to find the length, we set up a squared plus b squared equals c squared. Okay, this is 7, and that's 1. Here's our right angle. And if we go across in the right angle, we hit the hypotenuse. That's our missing side, so I'll call it x. So we get 7 squared plus 1 squared equals x squared. 7 squared is 49, plus 1 squared, which is 1, and then x squared. So that's 50 equals x squared. Or to get x, you take the square root on both sides. And the square root of 50, I'll write it as a decimal. I'll approximate it using a calculator, 7.07. Okay, so AB equals 7.07 units. Okay, and then repeat. I'll start the next one and then you can finish it. So let's investigate BC. Okay, step 1, make the little slope triangle. This side of the triangle is going to be 3 units long. This side is going to be 4 units long. Okay. It's going downhill. So the rise is going to be 3, the run is going to be 4, and it has to be negative because it's going downhill from left to right. Okay, then we use a squared plus b squared equals c squared. Here's a right angle. So if you draw a little line that shoots out of the right angle, it hits the hypotenuse x. 4 squared plus 3 squared equals x squared. All right, and you can finish that. AB, BC, and don't forget about also AC. And I think you're going to notice that CB and AC, these are related, and then AB is just unrelated. 8-84. Determine the values for A and B that make each system of equations true, i.e. solve each system. Be sure to show your work or explain your thinking clearly. All right, part A. First thing I'm going to do I'm going to notice that any number, actually, I'll let you solve part A. I'm going to solve part B. Okay, 8-84. First thing I'm going to do is solve this top one for A. I can solve the top equation by dividing both sides by b squared. All right, b squared and b squared cancel, so I get A equals 32 divided by b squared. Next, I'll solve the second equation by dividing both sides by b cubed. B cubed divided by b cubed, that cancels. So I get A equals, and I'm writing it in reversed order, 128 over b raised to the power 3. Okay, now we're going to use the equal values method. These things are both equal to A, so we can put them equal to each other. All right. Then use cross multiplication. 32 times b raised to the power 3 equals 128 times b squared. All right. What's tricky here is we now need to divide by the smallest power of b. We've got b cubed and b squared, so let's divide by b squared. All right, so on the right, b squared divided by b squared is cancellation. And then on the left, when you divide b divided by b, the exponents subtract. We did this in laws of exponents. So b to the power 3 divided by b to the power 2, that's b to the power 3 minus 2. And 128 is still on the right-hand side. So these two b's have subtracting exponents, and of course 3 minus 2 is 1. 32 b to the power 1 equals 128. Now b to the power 1, that's just b. I'm going to erase that 1. That's the invisible 1 right there, so we don't need to write that. So 32b equals 128. Last step, divide by 32. So our b is going to be 4. All right, now we go back up to these equations, and I can pick either one, plug in b to either one of these. This one looks a little bit easier, so let's use that one. Let's say 32 equals a times, instead of writing b squared, I'm going to write 4 squared. All right, now because of PEMDAS, exponent, order of operations, you always do the exponent first. 4 squared is 16, so a times 16 equals 32. I can divide both sides by that 16. That'll make a all by itself. And then 32 divided by 16 is just 2. Okay. Those are my solutions. Now a little shortcut for a is anything to the power of 0 is 1. So this top equation is just 6 times a. 6 equals a times 1. b to the power of 0 is just 1. a times 1, anything times 1 is itself, so a times 1 is just a. So there's a little shortcut on a. They give you the a value right away. So you can plug this into the next one to find b. 8-88. On graph paper, draw AC with those endpoints. Determine the length and midpoint of AC. Okay, we have A, which is 2, 6. That's our A. And then C is 5, -1. Okay, so this is line segment AC. How long is it? And what's the midpoint? I'll do the midpoint. For length, what you're going to want to do is just make the triangle. Make the slope triangle. All right. And then you've got 3 units down here. On the side, you've got 1, 2, 3, 4, 5, 6, 7. All right. And then here's your right angle. Here's the hypotenuse x. That's what you're missing. Use a squared plus b squared equals c squared. So I set that up for you. Try to find x. For the midpoint, remember that you take the average of the coordinates. So if you're looking at the x values, what you're going to want to do is add up those two x values. If you'd like, you can say x1, y1, x2, y2. But basically you take the x coordinates 2 and 5, add them, and divide by 2. Then you're going to want to take the y coordinates and do the same thing. So it's 6 plus -1, and then also divide that by 2. That's how you take the average of two numbers. You take the two numbers themselves, you add them up, and then you divide by 2. Alright, so that's going to be 7 over 2, comma, 6 and -1 make 5. And 7 divided by 2, that's 3.5, comma, 2.5. That's the midpoint. So if you go on your graph, 3.5, 2.5, it's always good to double check that the answer makes sense. It's saying the midpoint is right about there, which makes sense. That's right in the middle. Okay, 8-96. Write the function y equals a times b raised to the power x that represents each situation below. Okay, let's write one that passes through these points. So if you're thinking about a graph, 0, 4, and then we have 2, 1. So our graph is decreasing. Looks something like this. All right, now I say that the a value is 4 because look, the y-intercept is 4. So right away we know a is 4. So we can write y equals 4 times b raised to the power x. Then we look at our x and y coordinates here, 2 and 1. Let's plug in 2 for x and 1 for y. So that's going to be 1 equals, y becomes 1, 4 times b raised to the power, and then x is going to be 2. So it's going to be b to the power 2. All right, now we need to solve for b, so let's divide both sides by 4. And 1 over 4 equals b squared. And now what we got to do is, to get b, you take square root on each side. Square root b squared is just b. And square root of 1/4, that's the square root of 1 divided by the square root of 4. Or use your calculator. So you get b equals 1 over 2. Square root of 4 is just 2. So b is a half. Writing the equation, y equals 2 times a half raised to the power x. And that goes for b. All right, 8-97. Solve the following systems of equations. In other words, find a and b that make the values true, show your work, explain your thinking. All right, so this one, I'm going to do a. If you are confused on b, I solved a similar one up here for 8-84, so you can look at how I solved that one. Okay, 3 equals a times anything to the power 0 is 1. So this is just a times 1. 3 equals a times 1. And a times 1 is just a. So 3 equals a. Right away we know what a is. Now we need to find b. So to find b, we'll use our second equation. 75 equals a times b squared. Instead of writing a, I'll write 3 times b squared. To undo multiplication, I must divide. Divide by 3. 75 divided by 3 is 25. So 25 equals b squared. Take the square root on both sides, and you get 5 equals b. So a is 3, b is 5. 8-98. Kristen's grandparents started a savings account for her when she was born. They invested $500 in an account that pays 8% interest compounded annually. Write an equation to model the amount of money in the account on Kristen's 8th birthday. Okay, so we need our multiplier. We have 8% growth. So if we start at 100% and we add 8%, the growth can be described by 108%. Now if we move the decimal to the left 2 times, that's 1.08. B is 1.08. It looks like our starting value is given to us $500. So my equation is going to be, so we know our A value. A is the starting value, which is 500. If we use A times B raised to the power X, that's just 500 times 1.08 raised to the power X. All right, so it says the amount of money in the account on Kristen's 8th birthday. So X is the number of years. So for example, if it's her 16th birthday, then X equals 16. So what do? We take our equation and we leave everything the same except we replace X with 16. 500 times 1.08 raised to the power 16. All right, let's get the calculator on this. So you need to do the exponent part first due to the order of operations. We have 1.08 raised to the power 16. All right, and then we do 500 times whatever this is, times 500. 1,712 and 97. So I'm going to stop it after 2 decimals because this is money. You can have 97 cents, but you can't have 97.1 cents. That doesn't make sense. So sorry, what was that? That was 1,712.97. All right. Domain and range. Well, if you're thinking about an exponential function, specifically this one, the domain is all the x values from left to right. All right, and then we started at year 0, and it goes until forever, right? Until she dies. So maybe 0 to 100. She's assuming she'll live to be 100 years old. So that'd be a good domain for this. This money's going to keep growing all the way until she dies, assuming she doesn't take it out. How about the range? Well, we start at 500, and then the money grows, something like that. So the range is going to be 500 to infinity, or whatever's left when she dies. So I'm just going to say infinity. That's fine, assuming it keeps going forever, something like that. I'll let you sketch a graph. Make sure you label. Don't forget to label. 112. All right, let's do B. Let's write an equation in this form, and it wants us to use f of x. Okay, we need to find A. What's the starting value? Also, we need to find B. What are we multiplying by? Okay, the trick to find B, this one's pretty easy, as long as you remember the trick. You take the second number, the later number, the one at the bottom, and you divide by the earlier number. Okay, so that will give us B. B is 0.8. Okay, so to go forward in this list, we times by 1.8. So for example, to get to the fourth term, you do 77.312 times 0.8. And that'll get you 61.8496. All right, now if you want to go backwards in the list, you do the opposite. So instead of multiplying by 0.8, you divide. And we had to do this twice. Then we'll get to the starting value. So let's start with 96.64. 96.64 divided by 0.8. 120.8. That's the first term. Divide by 0.8 again. And that's 151. All right, and that's our starting value. That's A. A is 151. All right, so f of x equals 151 times 0.8 raised to the power x. Remember, f of x is the same thing as y, just a different way of writing it. Okay, an exponential function of the form a times b raised to the power x passes through those 2 points. What's the equation? Sketch the graph. I'll help you write the equation. All right. So we have a couple points. We make a table. Let's see how we do. We don't know what 0 is, but we know 2, 2 and 4, a half. So there's a couple ways to do this. You might just be able to guess that 2 divided by 2 is 1, and then 1 divided by 2 is a half. We need multiplying though, so that's the same thing as timesing by a half. Dividing by 2 is the same thing as multiplying by a half. All right, and if we keep going back up the list this way, you can see it doubles. A half, 1, 2, 4, 8. So there's a lot of patterns here. So we know from that our 0 term is 8. That's A. A is 8. And we multiply by a half to get to the next term, so b is 1/2. Therefore, y equals a times b raised to the power x. That's going to be 8 times 1/2 raised to the power x. All right, that's one possible way to do this. There's another possible way. That was probably the easier way. The other way to do this is you write y equals a times b raised to the power x. All right, and then you plug in this first point, you get 2 equals a times b raised to the power 2. Then you plug in the second point, again, make a second equation, and you get 1/2 equals a times b raised to the power 4. Okay, then you get a system of equations. This is alternate solution. All right, you have that system of equations, and then you use the same method as an 8-97 or 8-84. I'm not going to do that way because that's unnecessarily hard. This is the easy way. Don't work harder than you have to. 8-123. If f of x equals 3 times 2 to the power x, evaluate all these expressions, a, b, and c, then do d and e. Okay, so evaluate. What we do is you take this as our input, and we write 3 times 2 raised to the power. Let's replace x with -1 for this one. So that's 3 times. Remember, any exponents, any negative exponent flips what's on the inside. So 2 gets flipped. Now it's a half, and then the exponent becomes positive. So negative to positive, flip. That's just 3 times a half, and that's 1.5. Let's do one more of these. F of 0, that's 3 times 2 raised to the power 0. Okay, so that's going to be 3 times anything to the power 0 is 1. 3 times 1 is 3. All right, I'll let you do C. Let's look at D. What value of x gives f of x equals 12? Okay, so this is the other one. Let's not plug in this number for x. What you do is we have f of x equals 3 times 2 to the power x. Let's replace f of x with 12. So basically you set this equation equal to 12. All right, then divide both sides by 3. 12 divided by 3 is 4. We got 4 equals 2 to the power x. Okay, 2 raised to the power what? That's going to be 2, right? 2 squared, 2 times 2. So that means x, in this case, x has to be 2. If x is 2, the equation is correct. All right, I'll let you sketch this one. Just use your answers from A, B, like for example, -1, -1, 1.5. When x is 0, the output is 3, so you find 0 and you go up 3. Just use your answers from that one. And we got, when x is 2, the output is 12, 2, 12. It's a 0. All right, so just use your answers from above, sketch the graph.